Okay. Okay. Hello. So this is my current rating. Voice is there? Yes, voice is there. Okay. Let's go. 6 problems. Cool. 0 permutations, correct. Chef has an array of length and initially all elements are equal to 0. Transform the rest of permutation. Perform the following operation. N number of times select index. Update value of the index. Okay. After every operation, compute z as the number of indices such that both the adjacent positions are 0. Sum of z is the score. Minimum possible score. Okay. So once all the alternating elements have been destroyed, not 0. Once all the alternating elements have become non-zero, then so I have to just do those elements non-zero. Like in case of 4, the second and the fourth index I'll make it non-zero first, right? Yep. So how much of this does the score become? So first it will be 1. Okay. So it was like 0 0 0 0. When I made 1 here, now there remains only one index. This is the index where it will be counted for z. Then I'll change this index, right? So first of all, uh, what will be z at the end? I have to compute, right? First of all, z will be after removing 1. I'll have one more index for an even number. For an even number 4, I reduced this, so I got left with 2 elements. Okay, I'll just see with the size. Okay, int size is n, while n. So okay, first of all, n will get reduced by 2, right? And now whatever is left amongst that, no. Yeah, size of n will always reduce by 2. And how many indices over here? N minus 1. So z plus equal to n minus 1. And every time it will go by 2. Is this what did I miss? CNN n is greater than equal to 0. N is greater than 0 in fact. Okay, let's see. Crazy permutations. Correct. Let's go. Crazy permutations. Have has two permutations A and B of length, and here a permutation of length is okay. Wants to transform array into array B. Choose an index I and either increase AI or decrease AI after each of any number of times. Okay, any number of times. Increase or decrease. However, after every operation, the following condition must hold that the adjacent elements are unequal. Okay, I have to transform array A into array B. Okay. Intermediate values may become any integers, do not have to remain okay. Not a revolution, but the final value of the array exactly equal to B. Is it possible to transform array A into B? I see this line. They do not have to remain in 1 to n. So maybe we can increase all above greater than n and then do something. Okay. And where's the permutation here? Okay, both of these are permutations, right? Okay. Okay. So they can be any integers, right? But create, I cannot flip the inversion, can I? Because that is the test case where I'm like, I have 1, 2, 3. Can I make it into 3, 1, 2? Okay, at some point to cross this, see if 2 is greater than, oh, whatever. Okay. 2 is greater than 1, and here 1 is lesser than 3. So, what happened? Oh, space issues. Will it not work? Fine, keep it fine. Okay, 2 is greater than 1 and 1 is less than 3. So, at some point when I have to flip this inversion, uh, i- these two elements will become equal at some point, right? Yeah, I can do one operation at a time. So, I cannot flip an inversion. So, I cannot transform any array to any array. So, if it's like 3, 1, 2, can I not make it 3, 2, 1 also? No. So if both the arrays are unequal, then I cannot. I guess so. See, if I cannot flip an inversion, A and B are equal. Oh, C out, yes. Else, what happened? And else C out, no. See, if both the hmm, if the two arrays are unequal, what happened? Oh, sorry. D equals to less than Li plus plus C in Bi. If both the arrays are equal, only then was the transformation not possible? See, I cannot flip an inversion. What am I missing? Okay. Chef has two permutations, wants to transform array into array B by increasing or decreasing element by 1. After every operation, following condition must hold. Adjacent elements are unequal. Okay. Okay, so okay, only adjacents. So if it's 1, 2, 3, I can make it into 3 to 1. Yes. Yes, I can. No, I cannot. 3 has to go to 1. Okay, do something like this. 3 has to go to 4 and 4 has to go to 5. I don't get it. See, if To transform 3 to 1, I have to go downwards, so will have to encounter 2 here. But I don't want to encounter. Maybe if it was like this. Yep, then it's possible. Yes, it's possible. So if one has to go here, so if this element has to become 1, uh, if this has to become 1, then its left and right elements should not cross this. Cross in the sense means both okay, the minimum should be greater than 3 and the maximum should be greater than 1. Minimum should be greater than 3 and maximum should be less than 1. Yep. So, okay, next and back. Okay, prev. It's true initially. Okay, val is right now AI and I have to go to BI. If if val is less than and val, then swap. First of all, if both are equal, we can continue. Now, if I have to transform, if I is greater than 0, so if val is greater than equal to max prev and val is less than equal to min prev, let me make the false case. If val is less than the max prev and val is great and val is greater than equal to the min prev, this is one case, or val is less than equal to max prev, val is greater than, sorry, val is greater than equal to the max prev and n val is less than equal to the min prev. That means they will cross. So in this case, I can say you can see out no and return. Okay, and one more I think I have to do. If I is less than n minus 1, I can just duplicate this stuff. And plus 1, right? and return C out. Yes, here. Too much time here, man. Please, no. Okay. For an element, what did I do? This one stuff. So I have to go from AI to BI. Okay, this stuff is wrong. Shit. Okay, so if this has to go till here, the end point must not be between these. No, it can be. I cannot frame this, man. Let's think simple. If I have to go from 3 to 1, then the adjacent elements should not cross this range, or it should not start from bottom and end up between 1 or 1 to 3. Like it should not cross this as well as end up between this. It can end up from the top. Let's increase all elements beyond n and then decrease. That will be simple, right? So let's increase all these elements. It will be 6 and plus 5, 9, 8, 7 and 10. Now when I have to decrease these, right? So 8 will have to go to 1. So it should be greater than, okay, yes, this is it. Let's solve it this way. AI plus equal to n. For int equals 0, less than n plus plus. Should not cross this. 8, 8 will go to 1. So it should be, okay, fine. Let's check indexes. MP of BI is I. Now for auto key val MP. So the val, it is, okay, val is 1. and the IDX is the value A of I should be greater than less than both. If AI is greater than AI minus 1, IDX is greater than 0, and A at IDX is greater than A at IDX minus 1, or IDX is less than N minus 1 and A at IDX is less than A at IDX plus 1, then it is no, otherwise yes. Is this correct? I hope so. This is not needed. What? MP of BI is I, okay. And then for 1 it will say IDX is this. If IDX is greater than 0, it's not. IDX is less than N minus 1 and A at IDX. Why A? It's greater than. Shit, man. Oh, what? What is this? For index 1, too much time, man. Shit. No problem. We'll do the more. Okay. Scam was the third problem. It jumped to 4. Okay, nice. We are given an array of length where each element has the positive integer value or minus 1. It is given the even sum people. If AI is not minus 1, person I votes for the member numbered AI. If AI is minus 1, person I looks at the prefix in the array and considers only positions with not minus 1. Let frequency be the reach. Okay, if there's a unique value with the maximum frequency, person I votes be. Otherwise, if two members are the person that does not vote. Okay, so there's a unique majority, then it will vote. Otherwise, not. Given a member X, determine whether there exists a valid rearrangement of the known values such that X receives the unique maximum number of votes. Note the array of the other positions. You may only rearrange only the known values. Positions where AI is minus 1 must remain minus 1. Okay, so all the X should be in the prefix. Okay, A1 is not minus 1, so it votes for somebody. Okay, N is the length and X is the winner. Okay, 2 is the winner. So can I say 2, 2, 1, no? Since the vote counts are fixed, remember 2 can never have a unique maximum, right? Correct. There's no -1, correct. Here already it's the majority of 2, okay. 1 means, okay, the majority voted. Here it's the majority voted. This cannot happen. 2 will get the majority votes. Okay, 2 for 2, I can say 2, let 2 be here, then a 2 will be here. Yes, okay. And for this, so is it optimal to just rearrange and put all the x values at the beginning? Correct, let's see. You are given an array which elements are positive or there are n people numbered from 1 to n. If ai is -1, then the person I vote for the member numbered ai. If a is equal to -1, then the person I looks at the prefix a in the array and considers the positive positions j greater than equal to I, j greater than equal to frequency with this unique value with a maximum frequency, then yes, voted. Otherwise, not vote. Given x, x receives the unique maximum number of votes. That x wins without tying anyone else. You may rearrange only the known values arbitrarily among themselves. Positions where ai equals to -1 must remain -1. Okay, it is optimal to place all x values in the prefix, then place unique values. Like if there are multiple values of non-x, like let x be 1, and there are multiple values of 2 and multiple values of 3, 4. So 1, 2, then 1, 3, and 1 once 4, then again 2, 3, 4. This should be the loop. Yep, this should be the loop. Okay. Mm, let's see. And I have to get x here. Okay. If z is not -1, then I will counter it in map, right? mpx plus plus. Okay. Oh, z. mpz plus plus. Now I can say I have to place all x values in the prefix and then place unique values. Okay. So I should modify the original vector only, right? If mp of x, because first of all, if it's -1, then continue. If vi is -1, then you can continue, do nothing. If mpx is there, then we can do mp of x minus minus, and I can say uh, I can say vi equals to x. If mpx is 0, then mp dot erase x. Okay. Let's use a priority queue. No, just a queue. Okay, let's do like this. If z equal to -1, then you can continue. Otherwise, if mp dot count z is 0, then we can q dot push z. Okay, okay. Now vi equals to q dot front. We can say that, and then if mp of, and do one more thing, mp of q dot front goes minus minus. If mp of q dot front still remains, then we can push it back. Q dot pop, then we can push it back, right? So q dot push vi. Vi becomes q dot front minus minus, and q pop. If this remains, then we can push back vi again to the q. Right, this will keep on going. Let me check if my vector is built correctly or not. Okay. Okay, 1 2 1 2, no. Okay, what? Uh, hmm? And z not equal to x. Okay, 2 2 1 1 2 2 2 1 1. Okay, same 2 2 1, nice. 1 1 1 2 2. Okay, correct. Now for this vector, I have to calculate. Uh, First, let's clear this MP. Now I have to create INT max frequency I can take and the val. For int I equals 0, I less than n, I plus plus. If vi not equal to -1, then mp of vi plus plus. If let's create a tie. If mp of v of I is equal to max frequency, then tie is true, else tie is false. So what will happen is max frequency will become mp of v of I, and val will become vi. And if other ways, then again mpvi, no. Okay, if now vi is -1, so a member will choose whom? Choose val, because it has the maximum frequency, right? So mp of val goes plus plus. No, 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 mp will not go plus plus. Max frequency will go plus plus. If and okay, the tie will be broken. Yep. If val is x and not tie, see out yes. I feel there is something wrong in this uh, computation part. We'll see. Okay, this is no. Third one. Why so less submissions? Am I wrong? If there is a tie, then nothing will happen, right? This goes wrong, what happens? To find two and there's a tie. Let's create votes. Here, votes of VI will always increase, right? This will not happen. Votes of val will increase. So if it is not minus one, then votes VI plus plus. So three times one has gotten the vote. Uh, so three times one has gotten the vote. One times two has got the vote. Then four times. What? What's happening? Oh, If okay, right now the tie is true. If val is greater than max frequency, then I can say the tie is broken and max frequency is val and last is key. Else, if the value is equal to max frequency, I'll say the tie is true now. Hmm. If the algorithm is right, then my code is correct. This has much more submissions, man. What is this? Circular binary string, position here. Okay. Oh, what the fuck? So much correct. Okay. Anything else? Modulo? No, not modulo. Okay, I'm pretty close. Any overflows by any chance? No. It's a wrong answer. Wrong answer. Okay. It is optimal to place all x values in the prefix, then place unique values, right? So for a vi, I create a map and then q. If z is equal to -1, then continue. MP to count at 0. When z is not equal to x, only then I will push into q. And MP is plus plus. If vi is -1, then continue. If mpx remains, then mpx minus minus equals to x. Else vi is q dot front. If q dot front minus minus. Okay. This is not an error, but I'm just making sure. Okay. Vi is q dot front, q dot front minus minus. If it still remains, then q dot push vi. And then q dot pop. Construction is correct, right? mp dot clear. Okay, if vi is not -1, then it will surely vote to wherever it stands and the frequency increases. If the mapping frequency becomes equal to the max frequency, then it is a tie, sure. But if the mapping frequency is greater than the max frequency, then max frequency becomes this value becomes vi and tie becomes false. And while updating, if there's -1, if there's a tie, then continue. Okay, this is wrong. The tie will be as it is. Tie will not be broken. This should, yeah, this should give wrong answer, but now it should be correct. Mm, 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 mm. Hmm. Still on the same, let's guess. Okay. Okay. If there's a tie between, this is what it said, right? If A is not -1, then it will vote for the person numbered A. If it is -1, then person I looks at the prefix and considers only positions where it is not -1. Frequency of the times value is appeared. If there is a unique value with the maximum frequency, it means there is not a tie. If there is a tie, then it does not vote. If there is not a tie, then it will vote to the maximum appeared element. Yeah, right. That is correct. I don't tell you here we are correct. Now let's assume there is a tie. Maximum frequency is 0 and last is nothing. So for all the votings, so if it is case of all -1, then nobody will get a vote. What happens? Mm, how come there's a yes? A tie should originally be true. Why did they make that mistake? Okay, so tie is originally true and this always happens. Nice tie is true here and this all happens. If last is X and there's not a tie, then yes, otherwise no. What is happening? Hmm. So there is a tie. Okay. If the value is greater than the max frequency, then I know the tie is broken and the max frequency becomes val and the last is the key element. Else, if they are equal, then it is a tie. The placement is correct. I think we can move on from this. See if okay, we push into queues and then this, and then it is the queue dot front and yeah and yeah and yeah. Okay. VI becomes queue dot front and you okay, queue dot push, queue dot front, queue dot pop. Correct. Then MP dot clear max frequency and then value. Initial tie is true. Yeah, this case will give. Okay, I went wrong. What is this case? No, right. What could have gone wrong? We're given an array, each element is positive, -1. Should I skip this for now? Yeah, I should skip this. We're given a circular binary string of length n. Position wise, okay, and okay, circular. You are given a starting index k. You must delete all n characters from the string one at a time. The score starts at 0. First deletion must be at position at character k. After deleting at some position p, then it's okay, adjacent only. If I is odd, your score becomes plus c. If I is even, your score becomes minus c. After every deletion to the last one, your score must remain strictly positive. Yes, okay. Otherwise, print -1. But we are forced to start at position k. It is 1 based. Yes, it is 1 based. The first deletion is supposed to happen at k equals to this thing at index k. So after deletion happens there, we are forced to. Okay, shrinking does not happen, but the circular structure remains the same. Okay, so if I remove something, then I should first, if I am at k and I did plus something or plus 0, plus 1 or plus 0, then I should pick up the plus. I should pick up the plus on the other side. If I'm forced to do negative, then I should pick the smaller one. If both have 0, what about that? Then after that I'm forced to pick a greater one. I can anyways do this. I can pick both left and right. I'll pick this 0, then I'll pick this 0. But after that I'm forced to pick a positive one. So I can, from the kth position, okay, from the kth position, I'll go rightwards until I reach k back, or the summation fails. Similarly towards left. if the left and right cross, if the left and right cross, then it's good. So we start at k, but since I'm consuming a string, I'll do k minus 1. So string scns, we start at k minus 1. So int right pointer is at k plus 1, right modulo equal to n, since it's circular. If k is, so on even we subtract, right? So if k is even and si is 1, then we can surely say we cannot do anything. Now we start here, we can start at this, sum becomes sum is 0. Okay, if k is even, then the sum would be minus equal to, sum would be minus equal to s at k minus 1 minus 0, else sum plus equal to s at k minus 1 minus 0. This is the sum. Okay, now while right is not equal to start, what I'll do is, if right and 1, then I'll say sum minus equal to s at right minus 0, else sum plus equal to s at right minus 0. If sum becomes negative, then right minus minus and I can break. Otherwise I can say let it's fine, I can move on and mm, 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 mm. Okay, right minus minus, right mod equal to n, break. Otherwise I can keep on moving. Then I can do similarly for left. Start plus n minus 1, right? I can repeat this stuff. Okay, and while left is not equal to right, yep, that's it. Okay, do the same thing for right, for left. After all of this thing, if left equals to right, then I can say, otherwise it's minus 1, right? Otherwise I can say you can start from k to left plus 1, print k to left plus 1, then no, what have you added, man? Shit. Okay. Mm, I can only, it's currently adjacent, right? So I can do that. Then I can print k plus 1 to right plus 1 to right. Okay. For int I equals to k, I is greater than equal to left plus 1, I is not equal to left plus 1. What I can do is cout I plus equal to n, I minus minus, I mod equal to n, right? For int I equals to k plus 1, I not equal to right, cout I plus equal to n, I plus plus, I mod equal to n. This is not needed. I have to do the same thing for left first, then right, I guess. I misread the question. I is the move number. Oh no. Shit. I is the move number. So it's just simulation, but I fucked up. Is it just simulation? Let me confirm. Okay, so you delete at K, then the next deletion must be from the adjacent. You will obviously choose 1 if it's an odd move. If it's an even move, you'll prefer 0. 0 would never make a difference anyway. So if you're surrounded by ones and you are at an even move, then you're forced to do that. It's not my fault, right? If I'm surrounded by ones and I'm at an even move currently, I could not have avoided it, right? Okay, okay. Left is k minus 2 and right is k, and sum is s at k minus 1 minus 0. You add this, okay, and the add operation is minus 1 now, right? Every time op will be multiplied by minus 1. So while left is not equal to right, and when left is equal to right, then we are forced to do that, right? So that I'll simulate later. First, let's do this. Okay, if op is minus 1, then I would prefer if s at left, let's do right. If s at right is 0, I'll prefer that. So right will be plus plus right mod equal to n. Okay, else I'll be forced to do left plus equal to n, left minus minus, left mod equal to n, and I'll have to sum will add op into s at left minus 0, and after that op will be flipped. The else case here will say ki op is plus 1, so you'll prefer obviously the If sum is negative at any point, cout -1 and L return. Now sum will add hop into S at left -0. Right. Now if sum is less than 0, cout -1, else vector int moves dot push back right +1, moves dot push back left +1. Okay, and here I'll say moves dot push back k. For auto x moves cout and L. This is completely wrong. Let's just remove this. Yep. What happened? Oh fuck. Uh, okay, if left is not equal to right, if operation is negative operation, then I'll say right. If right is 0, if left is 0, what happened? Moves as 1. Left and right are equal right now. Just up into S left -0. Score must remain strictly positive. Does it reach here? It does not. Okay. Fourth index. So sum is 1. Let's just see out sum. Sum is 1. Then operation is -1. Correct. So it will say operation is -1. So it will say what are lefts and rights here. What silly mistake I'm doing. I'll have to debug this whole thing for that. Okay. Uh, right. Escape model. Shit, bro. What else? Okay, thank God. I'm so close in on this one. I have to solve this. Come on, let's do this. You're given an array of length n where each element is either positive or negative -1. You're granted a1 is not -1. If ai is not -1, then person I votes for the member numbered ai. Okay, if it is -1, then it looks at the prefix with those positions that are not -1. Then frequency v is calculated. If there's a unique value v, the maximum frequency, then I votes v. If two or more of then person does not vote. Given a member x, determine whether there exists any valid arrangement of the known values such that x receives the unique maximum number of votes. X wins without tying anyone else. You may rearrange only the known values arbitrarily among themselves. Positions where AI is -1 must remain -1. Okay. And what I thought was key, put all the members numbered x towards the prefix, and then each member should appear only once until their capacity is exhausted. Was this correct? Okay. Putting all x in the prefix is the best. And then putting each member just once ensures that they don't occupy the majority early on. Yes, so that is correct for sure. Okay, so let's go part by part. Is this part completely correct? First, I'll check that. So I created a map and then Q. If the vector is -1 here, then continue, nothing to do. Otherwise, I will do impz plus plus. If if it is not equal to x, and it is first time I'm encountering this element, and it's not equal to x, then I'll push z in the queue. Okay. Then while reassigning, if it is -1, then continue. And after that, I have to place something. Now, if x has some elements left, there are some elements of x left. So I'll place x and then I'll do mpx minus minus. Otherwise, what I'll do is I'll take the front element from the queue, put it in vi map minus minus. If there is still some frequency left, then I'll push it at the last. Q dot front will be pushed last and Q dot pop. Correct. Yep. So this part is correct. Now this is the part where voting is calculated. Okay. Excuse me. Okay. Initially there's a tie. Makes sense. Maximum frequency is 0 and the values are initialized. Makes sense. And there is a map of votes. mp.clear has been done. Yep. So if a value is not -1, so it will surely vote to that member. So votes of vi goes plus plus. And there's a member occurred, so mpvi plus plus. Okay, and if there was not, if there was a -1, then we'll check if first of all if there's a tie. If there's a tie, then you will not do anything. If there's not a tie, then val is the element with the max frequency. Votes of val will go plus plus. And to update the frequency, if this element has the max frequency now, if this element's frequency is equal to the max frequency, then there's a tie. If it is greater, then there is not a tie, max frequency gets updated and value gets updated. If it is less, then I have to do nothing. I have to do nothing. If the frequency is less than the max frequency, then nothing. So this part is correct. Okay. Now I have to find the person with the max number of votes and is there a tie or not. So I have to find the element and the max frequency is again 0, tie is true. In the voting, if the value is greater than max frequency, then there's not a tie and the max frequency becomes val and the last becomes key. If there is a tie on this, then tie equals true. And for a yes case, the maximum voted person should be X and solely X, so there should not be a tie also. Otherwise, no. What is wrong? So implementation is correct. Tie is true, tie becomes false, tie is true. That should not make a difference, but it's just for me. Okay. There are n people. A person votes to its member or is the maximum number of times value v appears in this prefix. Okay. Frequencies and button value we use this prefix, and if there is a unique value with the maximum frequency, person A votes v. This ordering is the best, where you put all x values first and then only single values of the remaining ones, such that this helps in making x majority for the maximum amount of time in the prefix. Ordering is correct. Yep, ordering is correct. Put all the x values first and then the rest of the values one each. Hmm. So this is correct. It is optimal to place all x values in the prefix and then place unique values. I take n and x as input, the vector as input, create a map, create a queue, mp.count z is 0. If vs minus 1 will continue, if mpx remains, then vi is x and mpx minus minus. Else I'll do is vi is q dot front, mpq front minus minus. If mpq dot front, q dot push, q dot front, q dot pop. Hmm. Tie will only be broken when it enters here, and if it enters here, then val will be initialized. So there is no problem in this statement. At the end, I just find which one received the max number of votes. Oh God. Can I frame just a simple condition like uh, one will not receive a vote only when there are X amount of X will not receive the majority vote on -1 when there are Y number of members appeared. X will not receive the vote when Y number of members appeared. Hmm, right. So, key val MP. If key is equals to X, then continue int y equals to 0. Y plus equals to min of val comma MP of X minus 1. So if X has appeared, so I mean each element must appear mpx minus 1 times only, and after that if an extra element appears, then there will be a tie and one will not get the vote. So one will not get the vote here, and this person will not even vote as such. And when will it hold? Like, people are not voting anyone. Hold will be only when if val is greater than mpx greater than equal to, so there will be a person holding. So if I go like this, if I go like this, okay, so if vi is not equal to -1, then vote this guy. Okay, now if vi and done equals to 0, done plus plus, so this guy is done. So these amount of elements are done. Okay, now else case, what will happen is if done is less than equal to y, hold will be plus equal to y also. If done is less than equal to y, then we will vote to x. Else if done is less than equal to hold, then we'll continue. Else we'll vote to this. Okay, forget, let's use this code again. Hmm, this ordering I feel is wrong. So to place unique values, I should first place all those who have a total okay. So if I'm placing one by one, already those will be the first to reach who have less okay, everyone will reach mpx -1. Now if they have to reach MPX. So they go one by one and hit MPX. This is a tie, so nobody will do anything. Now if there's an increase, so it will be the same always. Now this person should not increase. Okay. Once every guy has reached MPX, the one with the least votes received should increment, that is appear. So the one with the least votes should appear. Okay, so this is wrong. Now let's do this part again. See, okay, if if we have a minus one, if we don't have a minus one, then votes of this plus plus MPVI plus plus. Okay, and if MPX remains, so let's do this only. If MPX remains, then we will do MPX minus minus. First of all, votes of X will be go plus plus. 12 minutes. Fuck. If MPX, that MPX minus minus, votes of X will go plus plus. That's it. That's it. If MPX is gone now, the one with the least votes and MP remaining, right? For auto key val votes, for int I equals to 1, I plus n equal to 100, I plus plus, votes I is 0. If X remains, then this. Now if MP of this key is there, then chosen equals to key, and then we can break. Chosen is key and then we can break. So what will happen is MP of chosen will go minus minus and votes of chosen will go plus plus. This all will go in shit. If Vi is minus 1, if Vi is minus 1, then we can say bool tie is true, int max frequency is 0, and my last is minus 1. In the map, no, Now in MP, we can say this is not the value. Value is done of key. So MP of key minus done of key, or I can just go with done. Yeah, so done. If value is greater than max frequency, tie is false, and this value equals to max frequency, then tie is true. If tie, then you can continue. Otherwise, we can do votes of last plus plus, and if the last guy is X and there's not a tie, then you can do this. What is wrong? P of Z plus plus. If X is left, then X. Otherwise, the one with the least votes. Okay, I calculate map. Max frequency, value is minus 1. All the votes are initialized to 0. One with the least votes. Then I have to do this stuff. What stuff? This stuff. And the least votes. So this is the main frequency, right? This is not needed. This is not needed. If value is less than max frequency, max frequency value last equals to key chosen. Done chosen plus plus. Okay. One with the least votes and left value and some occurrences left. Okay, so this some occurrences are left, and then the value is the least. Value is the least. Chosen is the key. Done chosen plus plus. Vote chosen plus plus. And now member will choose the value which has the max frequency. If there's a tie, then you can continue with forward slash plus plus. Please, come on. Damn. This was a bad one. Bad contest. Okay, I did it, so it's kind of good, but man, that was so easy. So the mistake I was doing in the first approach was in the ordering. Okay, the code looks heavy. And the mistake was in ordering. I was placing all unique elements once each, but it was kind of a priority queue thing where you have to pick the one with the least votes. So that is what I did. I picked the one with the least votes and which has some occurrences left. So I'll pick that and place it. And otherwise, if it is -1, then I have to pick obviously with the one max frequency and stuff. So this is fine, and this is the checking part. Okay, cool. Rank is 106. Oh, minimum tree traversal. Okay, I'll surely solve this one. 2 minutes left. You're given a tree with n vertices. Should I just go through the problems and talk about it? Okay, zero permutation score. What was it? Yeah, so you basically had to first increase all the alternating ones, and that would be optimal. And so at each point, you'll reduce the sequence by 2, because if you're turning on one bit, I mean, you are incrementing one stuff, so you'll decrease the length by 2. And you have to keep on doing this until n is greater than 0. And for each length of zeros, there will be n minus 1 pairs of adjacents. So this works in that way. Crazy permutations. Yeah, so if you have to, so if you have to basically, just this is the main thing over here. So if the element in array A is currently greater from the greater from the previous element, so in array B it should not be lesser than the previous element. Basically, both should be greater than the previous element, and similarly for the next element, both should be greater as well. If it's the opposite case, then it's no. Otherwise, it's yes. So was it right? Delete for fun. This was simulation, I think. Yep, this was simulation. This needs no explanation, only implementation. So you create right and left, and then obviously when you have to subtract something, so you will prefer a 0 and not a 1. And when you have to add something, you'll prefer a 1 and not a 0. At any point, if sum is less than equal to 0, then it's -1. At the end, it's the same, and just keep on pushing the moves and print it. And this was, I stumbled upon it a little more than I should have. So it was just uh, you have to just reorder and then check this thing. So the reordering part was the thing that I told you don't have to. First, I was doing that you have to place all the X occurrences at the prefix, and then one each occurrence of the unique values. next. But it is like you have to a kind of priority queue thing where you have to pick up the place the element with the least number of votes till now. Makes sense, right? You have to pick the element with the least number of votes and keep on doing it. And if it's a -1, then just fetch from the prefix which element has occurred the most and increase its vote. And you may get it from here that it's less than equal to 100. So map will work over here. Like there are pretty few values, few members, so you can iterate a map each time. There might be any optimizations to it, but this is how it works. Okay, okay, fine. That's it for today.